Welcome to The Explainer. Today, we're diving into a genuinely fascinating conceptual leap in artificial intelligence, one recently mapped out by AI researcher Andrej Karpathy. Now, if you've been following the rapid advancements in large language models, you know they're incredibly powerful, but they have this hidden, fundamental bottleneck. What we're exploring today is a revolutionary concept called system prompt learning. And honestly, this might just be the blueprint for how AI models learn in the future. It's a huge shift from just tweaking complex mathematical weights to something that looks remarkably like human note-taking. So, let's jump right in.
I want you to imagine something for a second. Picture working with the absolute smartest problem solver on the planet. They can write code, analyze data, and synthesize massive amounts of text, literally in seconds. But there's a major catch. This genius has absolutely zero short-term memory. Once a task is done, their mind is wiped completely blank. It's kind of like the movie Memento, right? Where the protagonist has to rely entirely on tattoos and Polaroids because he can't form new memories. Well, current AI models are exactly like that protagonist. They've got extraordinary ability in the present moment, but when they face a brand new problem tomorrow, they can't remember the lessons they learned from the problems they solved today. They just have to rely entirely on instinct.
Okay, let's dive into this. Section 1, the AI amnesia problem.
To really grasp this roadblock, we got to look at how these models are actually built. Right now, an AI basically learns through two main phases. First, there's pre-training, where the model just absorbs massive amounts of data to gain knowledge. So it's learning facts, grammar, coding skills, and just a general understanding of the world. Then comes fine-tuning. This includes things like reinforcement learning, and it shapes the model's habitual behavior. It learns how to act, how to be helpful, and how to format its responses based on habit. But notice what's completely missing here. Neither of these two phases allows the AI to simply write down a note for its future self. Everything is baked directly into the neural network's weights, which, if you think about it, is a really rigid and incredibly slow way to learn a new trick.
Because of this setup, current LLMs are seriously crippled by this amnesia. They have no scratch pad, there are literally no lasting notes. Imagine an AI struggles with this really complex math problem, figures it out after a ton of processing, and finally gets the right answer. Well, that hard-won realization just vanishes the absolute second the chat session ends. Without a notebook to jot down, hey, remember to carry the 2 next time, the AI is forced to rely entirely on weak, persistent self-guidance through those static weights. It is an incredibly inefficient way to navigate complex logic.
Which brings us to Section 2, the missing learning paradigm. Now, if we look at how biological intelligence, specifically, human intelligence operates, we solve this exact amnesia problem effortlessly every single day. Just think about how human note-taking works. You hit a tricky situation or a tough problem, you figure it out, maybe with a lot of mental sweat, trial and error. Then comes the absolutely crucial part. You write a rule. You extract the core lesson, thinking to yourself, okay, next time I do this, I need to check the safety valve first. And finally, you reuse that rule later. You actually remember it next time because you wrote it down. This human cognitive behavior turns a fleeting experience into a reusable strategy. And importantly, this feels like memory, not just some subtle change in your underlying habits or weights.
And this brings us to the big reveal. System prompt learning. This is the missing paradigm. It's essentially the concept of giving the AI its very own notebook. Instead of just hoping a model slowly builds a good habit over millions and millions of training cycles, what if the AI could learn explicit strategies and rules simply by writing them down for itself in its system prompt? It's a mechanism for the model to capture its own aha moments and permanently integrate them into its future behavior. Pretty cool, right?
Let's look closer at how this works in Section 3, the System Prompt Playbook.
So, how would this actually function in a real architecture? Well, think of it like a stack. At the foundation, we have the familiar territory we just talked about, pre-training for knowledge and fine-tuning for habits. But right on top of that is the proposed missing paradigm. The model essentially reviews its own successes and failures, edits its own prompt to write or update rules, and creates an improved playbook for itself. This results in better future performance that comes from better, explicit guidance, not just altering the mathematical weights. We are literally talking about letting the model write its own playbook.
And just to prove that this isn't some far-off science fiction, we can look at how the most advanced models operate today. For example, there's a real-world instruction found in Claude's actual system prompt that tells the model, when counting letters or words in text, explicitly enumerate them step by step before answering. That is pure problem-solving knowledge right there. It's a strategy. Models already benefit immensely from this kind of explicit instruction stored as text. The only limitation right now is that these highly effective rules are currently being written and hard-coded by human engineers.
Compare this fundamental shift for a second. Instead of the old path of weights-based learning, where you do gradient descent, nudge the math, and just kind of hope better habits emerge, we're moving to system prompt learning. This is where the model reviews its work and immediately generates better performance through a self-written text-based playbook. Updating text rather than doing endless gradient descent is a massive structural shift in how an AI can iterate and improve itself.
Which leads us nicely into Section 4, why text beats weights.
You might be wondering, why go through all the trouble of creating a text-based playbook instead of just tweaking weights? Well, because strategy living in text is mathematically and practically superior. First off, it's incredibly data efficient. A single, well-written rule can generalize way beyond specific training cases. Second, text provides vastly richer feedback. Traditional reinforcement learning basically gives a simple scalar reward, like a thumbs up or thumbs down. Natural language, on the other hand, can say, hey, you failed because you forgot to account for negative numbers. Always check for edge cases first. That is infinitely more expressive. Third, text captures broad problem-solving strategies that transfer across completely different domains. Fourth, it makes the AI's internal logic totally transparent. It's human-readable, auditable, and shareable. And finally, it lets knowledge stay explicit and editable before we even decide if it should be permanently baked into the model's subconscious habits.
Let's just imagine what an AI's personal notes might actually look like in practice. It might jot down something like, when counting, enumerate explicitly, or if I'm uncertain, verify my intermediate steps. It might even write rules for really tricky reasoning, telling itself to break problems down before answering, or encode a prevention rule for a failure mode it literally just experienced. Just imagine a model carrying this personalized notebook into every single interaction, constantly updating it based on what works and what doesn't. It's a real game changer.
Let's wrap this up with Section 5, the next AI frontier.
To summarize the core thesis of this explainer, let's look at how this entire newly proposed stack works together. Knowledge, so the facts about the world, that lives in the pre-training weights. Habits, like tone and formatting, well, those live in fine-tuning. But strategies, the complex reasoning and the rules, those belong in editable system instructions. Therefore, true, continuous self-improvement requires an AI to have a scratch pad. It needs a playbook that it can actively reflect on and improve over time. The essence here is that an AI that can iterate on its own instructions unlocks a completely new, incredibly powerful learning paradigm.
Of course, because we're looking at the very edge of the research frontier here, we're left with some really fascinating open questions. If a model is editing its own playbook, how exactly should those edits work? What's the right granularity or format for them? Should the edit policy itself, the rules for how to make rules, be learned by the model? And finally, the biggest question of all. At what point should a piece of explicit written knowledge be slowly migrated down into the model's underlying weights to become a permanent subconscious habit? We definitely don't have all the answers yet, but this blueprint points toward an absolutely thrilling future for self-improving AI. Thank you so much for joining me on this explainer, and definitely keep an eye on how system prompt learning evolves, because honestly, it might just change everything.